Our previous two energies have been potential energies because they've been stored. They have the potential to do work. In this case, we have kinetic energy, which is the energy of a moving object. Remember, kinetic means movement, just like kinetic friction. So this kinetic energy is currently doing work. Like the car that is traveling, work is being done. The person running, work is being done currently. It's not have the potential to do work, but is currently doing that work. Our equation is that the kinetic energy is 1/2 the mass times the speed squared. So it is a scalar, just as all the other energies and work before it have been. Mass you want to make sure is in kilograms, speed is in meters per second, if you want energy in joules. Just like elastic potential energy, kinetic energy is always positive because mass will never be negative, and speed, it has no direction, so it's always a positive, but even if it were the velocity, which could be negative, it's squared anyway, so it's always a positive value. So anything moving as kinetic energy, like the person running, the car traveling, a skateboarder, anything moving has energy. We want to find a typical energy here, try and get a grasp here on what a joule actually is, how large it is. So we want to find what is the kinetic energy of a 2,000-pound car moving at 55 miles per hour. So this is something we're familiar with. The problem is we're familiar with the English system. So we're going to have to make some conversions in this case to solve for joules. So I think we've all been in a car that's moved at 55 miles per hour. We want to find, first of all, the mass. That pound is actually a weight, technically. We want the mass. So for every kilogram, that is equal to 2.2 pounds if we're on the Earth. So I will put a little stipulation, we're on the Earth. I don't think this car is anywhere else. So we take our 2,000 pounds and we convert it that there are 2.2 pounds for every 1 kilogram. And so we get that the mass of this object comes out to be around 910 kilograms. Let's exactly convert this here, and we get 909 kilograms. What we also need here is we need to go from miles per hour to meters per second. So we know that that is indeed the speed, 55 miles per 1 hour. First we'll convert from miles to meters. And if you're in track, you know that 1 mile is 4 times around, which is 1,600 meters. And an hour, well, 1 hour is 60 minutes, and 1 minute is 60 seconds. So that comes out to be 3,600 seconds in an hour. So our speed comes out to be 24.4 meters per second. At this point, we go to our equation. That kinetic energy is 1/2 the mass times the speed squared. Our mass being 909 kilograms, and our speed being 24.4 meters per second. So we get our kinetic energy, turns out to be 270,600 joules. Very large amount of energy here, it seems. So a joule is not really a very large value in and of itself. A joule is rather a small unit. So things like cars will have large amounts of joules.